Good morning, students. Unit 4 is Magnetic, Superconducting and Dielectric Materials. Already we have completed magnetic and superconducting materials. Now we learn the new topic, dielectric materials. What are dielectrics and how they differ from insulators? Both are non-conducting materials, do not conduct heat and electricity, but they have different function. Insulators are used as electrical insulations that prevents from electrical shock and other electrical problems, whereas dielectrics are used in energy storage devices like capacitor and battery. The examples of dielectrics are mica, ceramics, glass, rubber, ebonite. The ebonite is nothing but the usual cooker handle which is black in color. Glass, rubber, which are dielectrics, also comes under insulators under certain phenomena. Thus, we can say all dielectrics are insulators, but all insulators are not dielectrics. Dielectrics are in different form: solid dielectrics, liquid dielectrics like mineral oil, castor oil, petroleum, cooking oil, and gas dielectrics like air, hydrogen sulfide, hydrogen, nitrogen, propane. Air acts as a good dielectrics as they store more charges. What are the properties of dielectrics? Being insulators, the dielectrics do not have free electrons to take part in conduction. As a result, the energy band gap between the conduction band and valence band is greater than 3 electron volt. It has negative temperature coefficient of resistance, that is, as the temperature increases, the resistance of the material decreases. They exhibit piezoelectric, a phenomenon where a polarization is induced by mechanical stress, and pyroelectric, where a polarization is induced by temperature. Bad conductors do not conduct heat and electricity. But in Lee's disk experiment, we have seen when a non-conductor is placed between two metallic conductors, heat is transferred by means of conduction. Similarly, though dielectrics or insulators, they are going to store charges by means of polarization. Polarization is the process of inducing electric dipoles inside the dielectrics by applying an external electric field. What is electric dipole? The two charges plus q and minus q separated by a small distance r constitutes an electric dipole, and it's denoted by mu suffix capital E, and it's the product of the charge and distance separation. The amount of electric dipole induced in a dielectric is always proportional to the applied electric field, and it's given by mu suffix E is equal to alpha E, where alpha is the proportionality constant called polarizability. Important parameter to define dielectric material is dielectric constant. It tells you how much amount of electric field have to be permitted inside the dielectrics. So, it is the ratio between absolute permittivity of the medium and permittivity of free space. Being a ratio, it has no unit. Based on the medium and how electric dipoles are induced or polarized in the presence of external electric field, there are four polarization mechanisms: electronic, ionic, orientation, and space charge polarization. Electronic polarization takes place in an atom. An atom consists of positively charged nucleus and negatively charged electrons. When an electric field is applied, the positively charged nucleus tries to align along the direction of electric field, whereas negatively charged electrons move away from the electric field. This displacement or movement induces an electric dipole moment, and it's called electronic polarization. Ionic polarization takes place in ions. Example, sodium chloride salt which consist of Na plus ions and Cl minus ions. Again, in the presence of electric field, the anions and cations move either towards or away from the electric field and induce an electric dipole moment, and it's called ionic polarization. In orientation polarization, the polar molecules which have permanent dipoles will orient as a function of electric field. Finally, the space charge polarization, charges will start to accumulate at the interface, or that is the boundary between two different phases or electrodes. This can be understood with the following diagram. This is an electrochemical reaction setup. Here the electrolyte is a sodium salt solution. It comprises of Na plus ions and Cl minus ions. So the positive ions, anions, are attracted towards the negative electrode cathode, and the negative ions, cations, are attracted towards the positive electrode anode. The boundary between the ions and electrodes are called interface. To see more about orientation polarization, first we will define the polar molecules. Let us consider water molecule H2O. The bond angle formed between two hydrogen atoms is roughly 105 degrees. The size of hydrogen atom is much smaller than oxygen atom. Because of this, the valence electrons of hydrogen are more attracted towards oxygen than electron-electron repulsion. This forms a permanent dipole with positive charge at the bottom and the negative charge at the top. Such molecules which have permanent electric dipole even in the absence of external electric field is called polar molecules. On the other hand, carbon dioxide, CO2, the atom size are almost similar and the bond orientations between carbon and oxygen is one on left hand side and other on right hand side. Both the bond orientations are equal in magnitude and opposite in direction. Thus, they cancel out each other and they do not form polar molecules or net electric dipole. Thus, they are called non-polar molecules. To simplify further, the difference between polar and non-polar molecules are tabulated. In polar molecules, the net electric dipole moment has a finite value due to non-symmetric and irregular charge distribution. Whereas in non-polar molecules, the net electric dipole moment is zero due to symmetric, equal and opposite charge distribution. With this, part 1 of dielectric is concluded. Thank you.